currently runs the Cloud Languages team at Microsoft. A warm welcome to Erik Meijer.
Well, thank you very much. I must say, when I got invited for this talk, I was a little bit suspicious. Why would you invite a Microsoft guy, at an open source conference? But then I remembered, this is the Friday morning keynote. So that's why I thought maybe I can use this to do some astroturfing, which apparently is the latest Microsoft marketing machine. So this is astroturfing. So this is the question. What is a XXX language? So what is a dynamic language? Well, that's a language that has dynamic type system. What is an imperative language? Well, that's a language that is built using imperative statements. What is an object-oriented language? Well, a language that uses objects. So now you can ask the question, what is a functional language? Well, a functional language is a language that uses functions as first-class citizens. So now, what is a function? Well, our chief software architect of us programmers, Edgar Dijkstra, has, he writes these beautiful handwritten notes. I can recommend that to everybody. He has a definition of a function, but it sounds kind of rather academic, right? So let's just not look at that. But let's look at this. My daughter just finished high school, and she did her SAT test. And, if you look in that book, and there's many of these SAT prep guides, there is everything about functions. So they tell you what is a function. A function is something that whenever you give it an argument, it always returns the same results. It even says here there's nothing difficult about functions. It's easy. And they even tell you about function composition. Now the question is, we had on Tuesday, we had Dan Meijer here, like a high school math teacher who won an award, but something goes wrong. Because as soon as we leave high school, we forget everything that we know about functions. And why is that? Why do we suddenly, when we start programming, forget what mathematical functions are? Well, I think it's because of this. Because if you want to write a program that does any I/O, it has a side effect. So if you write, if you use console.writeLine, or if you use Java, it's like, printline or something like that, that's not a function. Because if you run this thing twice, it will kind of, do something different than when you run it once. The same when you read something, that's also a side effect. Even like looking at the time in a programming language, in an imperative language, is a side effect. So, what we conclude is that, these functional languages, they are, it's just academic nonsense. That's ivory tower stuff. Let's just forget it. Okay? And so let's just go and do imperative programming. However, as the great Frank Zappa said, don't eat the yellow snow. Okay? And it's really, really dangerous by taking these kind of, ideas of functional programming and integrating them into imperative programming. So let's look at some kind of, code to see what can go wrong. So here's a little C# program. And, if you don't understand C# and you don't understand LINQ, that doesn't really matter that much. I mean, I just would say go and learn C#. You can, if you don't want to use Microsoft stuff, you can use Mono. I think Mono now also supports C# Trio. But if you look at this program here, you see that it does two things. So first, it kind of, runs through some array, and it filters out all the elements that are less than 30. Then there's a big semicolon, and then it runs through the result of the first query and filters out all the ones that are more than 20. So now, what do you think that this program prints when I run it? Well, I've done these queries in sequence, so a normal person would expect that it first says, less than 30, less than 30, less than 30, and then more than 20, more than 20, right? Because that's the way my program is written. Unfortunately, because these queries are done lazily, the outputs get all mangled up. So now you get these things interleaved. So now we can say, let's use a functional language, F#. Well, F# is not really a fundamentalist functional language, so you will get the same result. No luck. Well, F# has also something called eager comprehension. So in this case, you get the result that you expect, except that in this case, you cannot compose queries. So you have kind of traded one disadvantage for the other. So that's not good. Let's look at some more disasters, exceptions. So here you're doing, there's a division there. So as everybody has learned in college, whenever you have a division, you have to put a try-catch around it because you can get a division by 0. Well, again, since that query is evaluated in a deferred way, in a lazy way, that thing will have terminated before you do any try-catch. The expression will just work, and then when you for each over it, the exception will be thrown. So that's really bad. So exceptions actually are extremely powerful side effects. They are even so powerful that you can simulate any other side effect using exceptions. So if your language has unchecked exceptions, it's extremely, extremely powerful effect. And this paper, if you really want your brains blown out, you can have a look at that. Here's another interesting thing. In C#, they have this thing called the using clause, because people don't trust the garbage collector, so they want to have an explicit way to dispose of resources. And you do that with the using statement. The problem is that when you make a closure over something that you allocate in the using clause there, it will be disposed as soon as you exit that using clause, and then when you call that function that you created there in the middle, your file will have been disposed, and you get an exception. Even more horrors. So here's like, a loop where inside the loop, I'm capturing that local variable. So what does this print? This prints 777. Now I move that variable, I capture that variable inside the loop, and what does it print now? 456. In JavaScript, when I run this code, it prints 666. It's exactly the same piece of code. In JavaScript, it gives a different result than in C# because the JavaScript semantics for variable capture are slightly different. And a third way, if I now lift that variable even out of the loop, now it prints 666 in C# as well. So just by moving this little variable in and out the loop, my program behaves completely differently. I don't know about you guys, but my brain is too small to comprehend that. And the funny thing is that if you look at OO programming, even object creation is a side effect. Concurrency is a side effect. So Erlang is not a pure functional language. So in Erlang, with concurrency, I can simulate mutable state. And you have to be really careful when you do that. People talk about REST and idempotence. I think what they mean is that they want purity. And how do you get purity? Well, we need to have types. And so here's the same example in Haskell. If you do it in Haskell and you try to do it, the type system, the compiler will tell you, sorry, Erik, what you're trying to do is impossible. You're trying to use a side effect, and so you're trying to use something that has a side effect as a Boolean expression. And also what Haskell shows is that you cannot forget about side effects. So in Haskell, there's this function unsavePerform.io, which allows you to forget side effects. If you allow that function, you can cast any value to any other value. And so you've kind of broken the world. So what should we do? Should we cover up effects like we do in these other languages? Should we remove effects? Well, if you remove effects, you are left with nothing. I can program in C by not using side effects, but that would be pretty bad. So instead, we should do what Microsoft is good at, embrace and extend. So we should just embrace effects. And the problem is that when you look at these things that have side effects, their types are wrong. So you have to kind of use this trick that we use always in computer science, is we should use an extra level of indirection. So instead of looking at something that has a side effect as a value, we should look at a computation. It's a collection of things. If I look at the time, system.datetime.now, it's not a single value. It's a stream of values. So that's kind of what we do. And again, the mathematicians have figured it out. And what you get here is that for every kind of side effect, you have a different notion of collection. And this is what, is the fearsome M word, monads. But it's nothing different. Everybody uses this trick in computer science. It's just an extra level of indirection. You're looking at something that has a side effect as a type, a special type that indicates that something wrong is going on. Okay, so if you look at Haskell, the operations like, read line and write line, now like the read line is a good one. Get char has type IO of char. Instead of returning a character, it returns a collection of characters. And every time when I call that function, I get a new value. So suddenly we have turned something that was not a mathematical function into a mathematical function. Now the question is, can normal people like us understand this? And I would say, of course. Look in the C# language specification, and it already has monads. Only they're called link. Okay? So they're disguised as queries, but really they are already in there. Java already has that. The throws clause in Java is a way to be explicit about side effects. And so if you would just, generalize that to kind of talk about all other effects, that would be fine. And Haskell is the only language that has this property where all the effects are made explicit. And the great thing about that is that in this new world of many core and concurrency, this allows the compiler, the Haskell compiler, to completely rearrange the execution order of your programs. And the reason is that these are mathematical functions, so the compiler has complete freedom, because it knows that whenever you call something and you call it twice, it will always be the same as calling it once. And this is guaranteed by the type system. And this is super important. So, what should you guys do? Well, there's a couple of good books about Haskell. For example, this one by Graham Hutton. So, as I said in the beginning, I'm here to astroturf. So what everybody should do is go and buy this book and then nudge Microsoft to kind of build a fundamentalist functional programming language. Or since we're here at an O'Reilly conference, you can also buy this other great book on Haskell. This even is called a real-world Haskell. Shows that, not even can normal people use Haskell, but they can even build real systems with it, which is amazing. But yes, so I can, recommend this book. And, maybe I can come out of my box and, next time show you the real Microsoft-sponsored fundamentalist language. So, with that, purify yourself. You are all sinners unless you program in a fundamentalist pure language. Thank you very much.